Okay, so welcome on this session of problem solving in engineering metrology. Today is the ninth session, and we'll be seeing a few concepts of statistics in meteorology. So let us begin with our session today. Okay, so let us go ahead with this. And as I said, the topic for today's discussion is statistics in meteorology. So before we move on to the methods of statistics that we use in meteorology, we should first look into the fact that why at all we need statistics for meteorology, and for that matter, what statistics does in general. So we very commonly use a term called stats, that this is the stat for, say, the average salary of engineers in India compared to the engineers in, say, Europe, or the weather data, the temperature and rainfall in eastern part of India compared to the western part of India, or for that matter, the growing cases of cancer in patients in India compared to, say, US. So, one thing that is very common here that I have termed is called compared. In all the statements I used the word compared. So, statistics is very important when you have to do some comparison between two groups of data or multiple groups of data. So, we have another term called as data. Now, what is this data? And why at all we need this comparison? And what are groups? So we'll look into all of these in depth. So data is the information, or rather the result of experiments, in very crude term, I will define data as the result of experiments. Whatever experiment you do and whatever result you get is data. And when we are discussing this, I would like you to link all of this to meteorology and what all we have done in meteorology. So till now we have done the techniques of meteorology. The techniques of meteorology, we said mechanical measurements, then we moved on to study sensors and transducers, then we studied a lot of factors that affect these sensors, and based on that, what is the output. So say we studied pressure transducers. Now where are you going to use these pressure transducers? For example, let us assume I designed an underwater pressure transducer to study the pressure of sea levels. Fine. Now, if I have to study the nature of seawater of the Indian Ocean, to say the Pacific Ocean, now one of the technique I can use is that I have this sea level, and below, to some extent, I put my sensor that I have designed, the transducer that I have designed, and I measure the pressure that is exerted on that transducer. Now what will happen is, if the height h at which I am measuring is kept constant, so the pressure of the water level because of this height should be constant. P1 should be equals to P2. P1 at Indian Ocean and P2 at the Pacific Ocean. But if it is not equal, then this relates to a fact that there must be some differences in the water nature of both the oceans. This can be one inference. Fine. So what all we had? We had a sensor or a transducer based on which we got data, and analyzing this data, we got what? Information. And this information in turn went on to become my knowledge. Fine. And this analyzing of the data is majoritarily based on statistics. Hence, the fact to which we opened the discussion with, that why do we at all need this statistics in meteorology, is to analyze the data that is being generated by the meteorological tools, and from that analysis collecting information, and that information going on to become knowledge, is the whole meaning of understanding statistics. Okay, so if this is understood, let us now step by step move on to it. So the first step was meteorology, wherein my tools generate I had tools, I designed the experiments, and from this meteorological tools I got data. Now from this data I have to from from this data I have to extract information, and that information has to become knowledge at some point of time. So we have seen this section of our part. So our concern today is this data. So when it comes to understanding the data, first method of it is data collection. It is very important for you to collect the data properly without errors. And for this, there are various communication protocols that you need to understand perfectly. And what are these communication protocols? These are, see, when in primitive times the data was to be collected, all the times we had one notebook. If you remember your experiments from your school, you all had that notebook in which you used to log the data. So every time we have to create a table, and in which we had to record the readings, and all this was done manually. Now, with the advancements in systems, we use computer based tools at all these stages of data analysis. So even at the data collection state, we use these computer based tools, and for this we must know the communication protocols. So my sensor has to communicate with my computer, and for this there are two types of communication broadly, although there is a entire subject on this which you need to study, but for brief we will study. There are 2 points of communication. One is called as serial communication, and the other is called as parallel communication. So what is serial? Serial is, say this is my device 1 which is my sensor, and this is my device 2 which is my computer. So if I have 8-bit data, now if I send 1 bit of data and it gives me an acknowledgement that okay, this data is received, I will send another 1 bit of data and it will again give me back one acknowledgement, and I'll again send 1 bit of data. So on and so forth. 8 bits of data will be transferred to the computer serially. Hence it is called as serial communication. In another format, say I have my sensor as device D1 and I have my computer as D2, and I have again 8 bits of data, and I choose to send all of it all together, all I need to have are 8 lines here, and all the 8 bits of data can be sent parallelly. So this is called as parallel communication. Now as you can see here, I just needed one data line, and here I would need 8 data lines. And based on the size of the data, the, the number of data lines will grow. So this anyhow is more costly to design. So in general, we use this serial communication for transferring the data, and for your understanding, USB protocol is a serial communication data. So it stands for Universal Serial Bus. So all the data is transferred serially, bit by bit, bit by bit, bit by bit. So data collection here, let us suppose that we will be using USB as our reference point for the further discussion. So from the sensor, all the data that has been collected should be transferred to the computer via a USB protocol. Now once the data is received on the computer, the next major step is data logging. This is where we create different formats of data storage. So for example, I have a .doc file, or I have a .xml file, or I have a .csv file, or I have, if it is an image, I have a .jpg file. Okay, so in all these formats, the data must be stored. So once the data is collected and it is logged onto your computer and it is saved, the first phase of data understanding is over. Next comes the analysis of data. And this is where mostly we will study the statistics. Now before we move on to statistics, I would like to refer to one point which is very interesting, that what is the kind of data, or you can say the type of data that is being collected. So we should understand that data primarily is of two types. One is continuous time data, and the other is the discrete time data. So how do we define continuous time and discrete time data is, let us say I have a graph of, again say, temperature values of a plant with respect to, so let us mark it as capital T and let us mark it as a small t. So this is my time axis and this is my temperature axis. Now if on all the time stamps, let us say I have chosen this to be milliseconds. Now if in every millisecond I have data floating like this, some sort of data, any random thing. So this is continuous in time. And it is very clear by the expression itself that continuous time data is that type of data which is giving values at every time instant that you are studying. So for t is equals to 0, I have some value of temperature. For t is equals to 1, I have some temperature. For t is equals to 2, and so on and so forth. I have a temperature value for every single instant of time. That is called as continuous time data. Analogously, what should be discrete time data? Again, say this is my temperature axis and this is my time axis. So if I have a temperature value at say t is equals to t naught, and then I do not have some value, and then I have temperature value at t is equals to say t3. So for t1, t2 I don't have any value. T1 and T2 I don't have any value. Then again for T4 I don't have any value, and for T5 I have some value. So this is what is called as discrete in time. That is, for all the instants of time we do not have the temperature value. We have discrete data. And this can be random. It is not supposed to be a very fixed pattern that you will get. It can be discrete at any sense. Fine. So we have two kinds of data. And based on the two kinds of data, our methods of analysis will change. They'll be different for continuous time scale and discrete time scale. Okay, now coming towards slowly towards statistics. So we all know a bit about statistics, and in general we know what is mean, what is median, and what is mode. These three things we know very well, and they are the measures of the central tendencies. Now, before going on to the mean, median, mode, and more about that, let us slightly discuss about what exactly is the need of statistics. So, as I said, we need to yield information from the data. Now, let us take an example. Let us say we have a company that is making iron bars. Okay. Now, for making this iron bars, the raw iron that it is getting is from three different parts of, say, India. Let us say state A, state B, and it is state C. From three different states, it is getting raw iron. And from that, it is doing some processing and it is making iron bars. Now, when these iron bars were sold, they got a report that there is a section of their batch in which rusting has been reported by the customers. Now it is important for them to analyze where things have gone wrong because of which the rusting is happening. Okay, so rusting can happen because of the raw material. The raw material at some point is reacting with water. Because of this, rusting can be there. Rusting can be there because of poor processing. They did not process it well, so because of the lack of some chemicals and increase of the oxidizing agents, the rusting has started. It can be because of poor handling. The way it were meant to be handled, they did not handle it well. They stored it in open water, and because of which the rusting happened. So there can be these three probable relations. Okay, so I used the word probable. We are not sure what is the cause, but these three are the causes. Now again, raw material comes from three parts, A, B and C. So if we have to identify what is the reason of this being, I say that okay, 1 by 3 is the probability of all of these three, all can be equally responsible. Now if this 1 by 3 is the probability for raw material, this again can be 1 by 3 of 1 by 3, so this can be 1 by 9. 1 by 9 and 1 by 9. So out of 9 possible reasons, one reason can be that rusting has been occurred because it came from state A. So this is the information that I got extracted from the data that I had. And data was that I had raw iron from three states. We have raw material handling problems, we had poor processing, and we have poor handling methods. So this is what statistics does. It gives you numbers, figures, graphs for better understanding for better understanding for better understanding the data. Okay, so starting again from metrology, we were taking measurements, we were doing measurements, we were using different techniques of measurements, and based on all the techniques we said that we need more accuracy, we need more precision, we need less errors, and all this thing yielded into generation of a lot of data, and that data has to be studied and analyzed for better better understanding. And what does this better understanding does? It helps you in decision making. So if you are at a position of taking decision, statistical data will always give you insights about your processes, and based on that understanding you have to take decisions. So if we take the previous example and it turned out that okay, the problem was arising from the raw material that came from state C, we have to then go down to understand that okay, should we purchase the raw material from state C? So this is one question. Now again another question arises is, if we do not purchase from C, do we have an alternative resource? is state A or B going to give you more raw material? Because being a company, being owner, you have to do that much production. Okay, so from this again another question arises: is the alternative resource feasible? So let us say state D was ready to give you, but state D is so far off that your logistics cost will increase so much that your manufacturing will fail at some point of time. So is it feasible? Is it giving you the same amount of returns that C was giving? So these are the questions that arise, and you as decision maker has to do it. And to assist you, there is always stats. There are figures and numbers, graphs, plots that we'll see in the coming part of the section. Okay, so the the reason to do this entire stuff is the maximization of the expected gain. And it can be anything. It can be a company, it can be a hospital, it can be a university. Case scenarios can be anywhere. It's just not the monetary gains. It need not be monetary gains. I mean, not overlooking the fact that monetary gains are there, but it can be other gains also, not just monetary gains. Okay, so to do all this, there is a thing that is called as loss function. So we define a function which is proportional of time, cost, say resources, and at each term, say t is equals to x, we try to identify that what is the loss function, what are the loss we are occurring at t is equals to x, at c is equals to x, and at r is equals to x. What is the loss function that we are generating? So for different values of t, c, and r, we will get different loss functions, and our aim is to minimize this. So minimization is very simple for me. D by dt of this f should be something that you know. If you remember the concept of local minima and local maximum. So these two are corollaries of each other. The gain can be only maximized when the loss function is minimized. Okay, so now coming on to stats. Uh, we have data, and this data is classified into two types. One is the population data and the other is the sample data. Okay, let us understand this fact clearly. So let us consider the case of India. Now, if I say I have 1.5 billion population, fine. And if I have to tell that, okay, how many people can write slash read English. So this is one decision that I have to take. Okay, how many people can read and write English? The reason for this can be I am a newspaper agency from, say, US, and I want to have the circulation of my daily newspaper, and I have to decide that should I start my daily newspaper in India or not. So my first question is, will people buy the newspaper? Okay, why will they buy the paper is the next question. So there can be many factors, but the first factor is if I am an English newspaper publisher and I want to publish in India, I must know how many people read English newspapers. And for that, I must know how many people first hand know how to read or write English. Fine. Now, if this is the case, that will people buy? So if this is the question, there can be two answers, yes and no. No can have two reasons. People, or maybe more reasons, but two reasons that we will list is people do not know English, or people read another English newspaper. Okay, so if they are hardcore readers of some, say, Times of India or the Hindu, they will never come on to your site. So these many people are out of context for me. And if there are people who do not know English, they are again out of context for me because I'm not going to make them teach English in order to make them read my newspaper first. This can also be a CSR kind of a work which people can do, but let's not go into that. So, will people buy the newspaper? There can be a section yes. And why will they buy the newspaper? There can be again multiple reasons. First of all, they know English, but do not yet read English newspapers. Or they read another newspaper, which they are not hardcore fans of. They can be broken down. So these two are my concerns. So what we have done here in all this setup that we made, yes, no, yes, no, yes, no. What we did was we qualitatively defined problems and deduced solutions. But this is all qualitative, right? I cannot affirmly say that, okay, my newspaper will start circulating. For that, I need quantitative data, and that is given by numbers. So, if we dig deeper into this, what we will identify is that for 1.5 billion people, I need to knock each door and ask every person, okay, do you read English newspapers? They say no. Then I say, do you know how to read English? They say no. And I mark it down and I move to the next door and I knock it. Okay, so if I am doing that, taking data from the entire population of interest, then this will be called as population data. I am going at each house, knocking them, asking them, and I create a repository of 1.5 billions. So I have a box in which I have data about all the 1.5 billion, and this is my population data. Now, another concern what comes here is talking to 1.5 billion, how much time it will take, how many people it will take, what all resources it will take, and all this combined will tell you what is the total cost it will take to survey or collect the data from 1.5 billion people. And this surely is something nobody is going to spend. Huge amount, huge amount. Now, what to do if I am not going to address 1.5 billion people? How do I take decisions? So, a very important and very interesting theory here comes in, and that is called as the sampling theory. And this is very, very important for statistical decisions, and even for any kind of data that you collect. Sampling the data is very, very essential, very, very important, and you have to take utmost care of how your samples are being taken. So first, let's understand what is the sampling theory and what are these samples. So in the same example, if we said that surveying 1.5 billion people was a very huge task that was not feasible in terms of the resources being utilized. So what we can do is we can take a chunk of data from the entire lot. That a lot means this PD, the population data, and what we can say that is that this sample data SD is what is representative of the entire population data. So from that box wherein I had the data of all the population, I made another box in which I put different samples of data. So this was population data and this is sample data. So sample data is a subset of population data. So instead of knocking all the doors in India, what I can do is in every district I can knock say 1,000 homes, and from that I can gather information. And hence from based on that I can say okay, these many number of people or these many percentage of people are knowing English and willing to read English newspapers, a quality in English newspaper. Okay, so it is very important for you for having from if you have big data, lot of data. So it is important for you to sample the data and create sample data. Now you as you can see that the first question that arises is if I have 1.5 billion people here and I let us say I roughly measured 1 million people here, so is this 1 million properly representing this 1.5 billion? The first question comes. I can say yes to understand English. The person next to me can say no. And if you take my data and based on that you take decision for the next person, so your distribution is already gone by half. Fine, so it is very important to decide how do you sample your data. And your sample should be bias free. It should not have any bias. What is bias? Bias is the undriven favor to a specific sample. Another example can be in the same context. Let us say that uh, I had decided that instead of 1.5 billion people, I will take the data of 1 million people, and based on that 1 million, I will take the decisions. Now, if I wanted to circulate my newspaper in all of India and I gave this task to do the survey to a surveying agency who was based in Kerala, and they decided that okay, they will take all the surveys in Kerala, all 1 million people will be from Kerala because their office is in Kerala, so they do not want to move out of Kerala and they'll take the decisions there. So if all the 1 million people are taken from Kerala, where the literacy rate is around 99% in urban areas, the data will already be false when it is applied to the rest of India. Why? Because the literacy rate here is very, 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 very high as compared to other parts of the country. Let us say if you talk about Bihar, where the literacy rate is low, or maybe the tribal areas of Chhattisgarh and Jharkhand, where the literacy rate is low. So your data is biased. Your sample is biased here. Fine. So it is very important for you to take the samples in such a manner that they are bias free. Fine. So let us now move on to once we have understood the factors of mean population and the population and the samples. Now let us move on to study some of the data samples, and the first thing that we should know always is the mean, or what is called as average in common terms. So if I have a distribution such that xn is equals to x1 comma x2 comma x3 comma x4 comma so on and so forth xn. So this is my data sample. Let us say this is the data of electricity consumption of states of India annual. So we have whatever number of states, and there is annual electricity consumption of these states of India, and I have this data here. For all the states, I have this data in, say, kilowatt hours or maybe kilowatts, 1000 kilowatts, 10,000 kilowatts, whatever. For all these states, I have the data in kilowatts. So this is my distribution, data distribution. Now, if India has to make a policy on electricity consumption, the first thing that you should know is that what is the actual consumption of the country. Fine. So actual consumption is what? Actual consumption is actually summation of xn from n is equals to 1 to xi summation of xi from I is equals to 1 to n. You add all these and you will get the total consumption that India is doing. Okay, but if you want to analyze the data state wise, the first thing that you should know is, say x1 was some value 10 or 1000, x2 was some value 1500, x4 was some value 200, x3 was some value 3000. Because all the states are different in size and their population is different in size, you cannot decide a policy of one state based on the other state. So total consumption will not give you a inference out of it. So hence we decide that we will take the mean of this, that okay, what is the mean consumption per state. So what we do here is summation I is equals to 1 to n xi upon n. So I divide this total data by the total number of states and I say that the mean consumption annually per state. So it will give you that every state uses this much and the mean consumption of the country is this much annually per state. So what comes out to be something seen as a number that is representative of all these states. Okay. Now this mean is a very mean term in the in the fact that, say in the same example you see that x3 was consuming 3000 units and x4 was consuming only 200 units. Now if you want to compare x3 to x4, it is very difficult for you to understand that on what grounds you can compare these two data. Okay, so if the mean comes out to be say something nearly 2800, so this mean is more close to this rather than this. Hence, the next term that we should understand here is the standard deviation. So this standard deviation is the deviation of single unit from the mean data. So we define the standard deviation as under root of summation xi minus mu whole square upon n. Okay, so if you see closely, this mu is the mean. So what we are trying to do is, let us say I have xi and I have xi minus mu. So if this value is 200 individual value and the mean was 2800, so my 200 minus 2800 goes on to become 2600. This is the normal difference of one state. And if one was 3000, so my value becomes. So these are all individual states differences from the mean value. And how do we compare all these on one single scale is this method of standard deviation. And there are a lot of terms that we should solve and understand well, but the few that we will discuss in this class, the another term that we should know is called as the range of data. So say my xi was x1 comma x2 comma so on xn. So the range R is xi min comma xi max. So let us suppose say that this data, the minimum value was 200 and the maximum value was 3000. So the range will go on to become 200 comma 3000. So the minimum data is this and the maximum data is this. Okay. Moving on, there is a very good thing which is called as probability density function. PDF. So what it does is it gives you a likelihood or probability of values falling in a range. So the probability distribution function graph looks like something this, and this is called as the normal curve. So this is my extreme limits, and this is the portion where the density is maximum and most of the data should fall within this range. If we get a curve like this, or like this, then these are called skewed data. Now what is the difference between normal data and skewed data? So if you see the normal curve here, which was this, you can see that most of the data lies in this range and the extremes are at the corners. So if this is my mean data, if we have used the so most of my data is falling near to the mean data. What does this interpret this? Most of the data falls near the mean data. But what would happen in this case, or in this case, the data is shifted to the left and here the data is shifted to the right. So they are skewed about a point other than the mean of the data. So this means that for if we have 10 people in the class and the height of people is say 100, let us say the weight of people, weight of 10 students is very basic pre-class people. So if the weight is 30 kgs, which is I suppose higher, 32 kgs, 28 kgs, 31 kgs, 27 kgs, 24 kgs, again 28 kgs, 1, 2, 3, 4, 5, 6, 7, 8, 28 kgs and 28. So if this is the data of 10 students of a pre-class, and we see that the average of this is something near to 30, and there is one value which is 100. So if you want to plot the distribution function of this, it would come something like, instead of coming like this, it should come something like this, wherein the data is shifted towards 100, which is not exactly representing the entire population. So this 100 is an outlier which makes my data skewed. So while analyzing the data, it is very important for you to pre-process the data before starting to draw conclusions. This is very important stage wherein you have to rectify errors of collection, outliers, and random errors. So with this, we will close our session today. And in the next session, we will start with more on the numerical approach of the statistical process, and we will see a few examples with the statistical approach in the meteorological systems. Okay, so thank you for today's session. Thank you.